Hello everyone, welcome to the EqualLogic training demo. Today you will learn how to better position EqualLogic. You'll go through a demo training, what's in it for me, and then we'll talk about some highlights and some talking points. Everybody knows today that Dell is the leader in storage. They are also the #1 in SCSI storage, iSCSI storage, and 98% of our customers recommend EqualLogic. Some of our top customers would be Michigan University, the Army, and the Navy. So with that, I'm going to leave you with Jason K., who will be doing the demo for us, and he will be also answering some of your questions regarding EqualLogic.
Thanks, Maria. Appreciate it. For those of you that don't know me, my name's Jason K., or Jason Kwiatkowski. I'm local here in Austin. I'm a regional manager. I manage a team of storage specialists for the channel group. And as Maria stated, we have an EqualLogic demo system here. This is a PS5000E. This is our flagship storage product. And we're going to walk you through what our guys in the field actually spend time doing in front of customers every day. And that's walking them through a basic installation and showing them the feature functionality of the product. So how many people in here have seen an EqualLogic array before? Actually physically seen it? So about one person in the room. How many of you been through training or seen an online WebEx? So a few more. Okay. How many of you have sold an EqualLogic array? Everyone. Okay. So the question is, and I guess the intent of this session is, would you feel more comfortable, or hopefully you'll feel more comfortable selling this product if you can see what it is, see what it does, not be afraid of it, not have it just be some mystery product that you don't really know what it's all about. So that's the intent, and hopefully this will be of value. So this is the actual physical product. This is, as I said, a PS5000E, so it's a rack-mountable storage device. It doesn't run Windows or Linux. It's all proprietary, so this comes from the ground up, produced by EqualLogic. It runs our own proprietary operating system on it. So if I look at this at a glance, what do I see? I see 16 something or others in front of this. Well, they're disk drives. And if I were to pull out one of these disk drives, you'll see just a normal everyday drive, right? If I turn this guy around and look at the back of it, I see power supplies, I see something like what might be fans, and I see these two guys right here. These are the controllers. So these, think of it as blade servers, right? These are two servers that are actually running our operating system that are driving this device. They connect out through the network and actually interface with a customer's servers on a back-end SAN. So that's all it really is. It's a bunch of disk drives, some intelligence that manage the disk drives, manage the connections to the servers, and some redundant power supplies and cooling systems to keep it powered on and cool. It's important to know, and customers will ask you, data storage relies on something that's very resilient. You might hear the term 5 nines thrown out there. It's, how often is this thing going to go down? Will a hardware component failure bring this system down, or can it sustain a failure and keep on running? So it's important to note that everything here is redundant. We have redundant power supplies, controllers, cooling systems. The disk drives have redundant drives built in. Everything in here is hot pluggable. So if I were to lose a power supply through some type of hardware failure, I can walk over, pull out a single power supply. The system can run just fine off of one for an indefinite amount of time. But the important thing to note is that I can replace the failed component without disrupting access to the device. So if you lose a server on your network, you basically lose the application that server was running on. If you lose your storage, all bets are off. You're losing all the applications that depend on that storage. So it's very important to build out redundancy in any enterprise type of array. So what I'm going to do now is I'm going to actually connect these cables. So I'm going to hook up both power cords. I'm going to put a network cable in here and a serial cable to do some diagnostics view of the array. Now when I turn this puppy on, you're going to hear the fans start to kick in. It's going to get loud initially. It's going to sound like a jet engine taking off. And then depending on the temperature of the room, hopefully it's going to settle down a little bit and just keep this at a sustained ambient temperature. So we're actually going through a boot cycle. This is booting up just like any other server would. So regarding this product, as this is coming online, you might know that it comes in different options, right? The power behind this product is this in itself is a self-contained storage area network. What that means is servers can connect over a network. They can attach to a remote disk drive. So Eric's going to show us here in a few minutes how we walk through the interface and the management system. You create what looks to the operating system like a local disk drive, except it's contained in this unit. So it's presenting out a virtual disk drive across the network. So this unit in itself is a SAN. It comes in different types of drives that can be installed in it. So I don't know if you're familiar with SATA drives or SAS drives. SAS drives typically are your higher end, your 15K RPM drives, your 10K RPM drives. They're for your more transactional demanding applications like SQL or Exchange or Oracle. So if you're talking to a customer, they say, I need a shared storage device for my Oracle database, you would typically think perhaps they push them towards SAS drives, which are a little bit more expensive, but they're higher performing disk drives. SATA, on the other hand, are typically lower performing, but they're higher capacity. So if someone has a 10 terabyte data requirement and they're going to be running files or Exchange, but they don't have that many users, they might want to go with SATA because it's going to be less cost per megabyte stored. So the interesting thing about this product is that although this is a self-contained SAN in it of itself, they can be logically combined with multiple what we call members within the same virtual SAN. So multiple PS5000s stacked together will work in coordination with each other to present a large contiguous pool of storage for your end users to manage, create virtual drives, and use as a consolidated storage system. Make sense? Any questions? You guys are all pros? Good. All right, so Eric is going to be driving our demonstration. He's over there at my laptop. So I'm going to be kind of directing him around, and we're going to go through what a customer goes through and what a customer watches when our storage specialists go on site and demonstrate this product. And it's also the same process that our customers go through when they receive the product from Dell and have to install it on their network for the first time. So we've tried to make this product as easy to use as possible. Historically, storage has been this very cumbersome, difficult beast to manage. And one of the things that we did at EqualLogic and now Dell is we tried to make this as easy to use as possible. So we have something called the Remote Setup Wizard on the screen. Eric's going to launch the Remote Setup Wizard, and what this is going to do through our network connection, it's going to detect a unconfigured EqualLogic storage device. So go ahead, and Eric, and hit Next. So we're actually probing the network right now to see if there's any EqualLogic arrays that happen to exist on the network. All right. As you see, the Remote Setup Wizard will detect an array sitting on a network that's not been initialized. And what this is going to do is walk us through a series of steps to get the initial configuration on the array so servers can see this on the network and manage it and connect to our virtual disk drives. So Eric, if you would, can you hit Next? We're going to type in a member name. That's a way for us to identify this physical hardware sitting on the network. So let's go ahead and type in PSA for Pure Storage Array. And for IP address, if you're not familiar, it's kind of the phone number for a device sitting on a network. So for IP address, we're going to type in Eric 10.10. .10.51. And then subnet mask, that's to determine which subnet, so you can logically split up a network into subnets. We're going to type in 255.255.255.0. Good. Now you see two options here for group information. So two options